Thank you. Okay, so here's what we're gonna do. iPads away. iPads away. Nope. Away. 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 We're gonna walk through this together, and you're gonna resubmit it. Okay? You're gonna submit it to that same assignment, completed, and then I'll have reference for here's how it looked, and now do we have it figured out? Do you want new papers?
Yeah.
You do? Here we go. Yeah. Yeah, if you leave your phone up here. Okay. So, talk to me about this. By the way, you guys, I feel like you guys are going to rock it if you take Algebra 2 someday with the calculator work that we have done in this class. Because can I tell you, my Algebra 2 students who did not go through this class keep screwing up this. And I think you guys do a better job than they do. So kudos to you. Tell me what we do with that 8 and 36. Nick.
Do 8 divided by 36 and PRB.
Mm-hmm. Put it in your calculator. 8 divided by 36. Plug it in. 2 nines. When you go second PRB. Okay, you get a decimal. You hit second PRB. Hit enter. And you get 2 nines. Okay, so essentially you could do divide both by 4 if you don't feel like plugging it into your calculator. But I think your calculator is majestic in this and so lovely, and I think you should use it. So 2 ninths. Okay, take a look at your M's. You can only do division if you have the same base, meaning they're both an M. M to the 4th over M to the what? A first, okay. What do you do with that 4 and 1? You subtract them, which gets you what number? 3. M to the 3rd goes where for this one? Top or bottom? Top. Why on top? The bigger number was on top, so you got to keep it. It's like saying M times M times M divided by M, right? These will go away. You're left with M squared on top. Okay? Then look at your next one. N squared over N. What do you do with 2 and 3? You subtract them. You get the number 1. Where does N to the 1st go? On bottom, because you have more N's on bottom. So N to the 1st on bottom. Is there anything else you can simplify about this? You're the second person that's called me ma'am today, and it's really making me feel old. I know. But I am old. Thank you. 30? Yeah, totally. Yeah. Okay, this one. The 3 sounds like it was freaking some of you out. Let's just look at this right now. Do you see a GCF? Is there something you can factor out of all of that? You can factor an X out of it. So if we factor an X out, essentially you're dividing by X, dividing by X, dividing by X. What you're left with then is an X. And when you've done that, now there's an X squared. Will you push the thing out so that Brooklyn can get back in? Thank you. So X squared minus what? What's X squared divided by X? X, right? It's just 1X now. Plus, what's 12X divided by X? 12. Now that should look like something you know how to factor, right? No? Okay, so that's your new numerator right now. Is there a GCF on the denominator? Yes. X, right? You can take an X out. What are you left with when you take an X out? X squared minus 16. Okay, now if I were you, I would simplify this before I factor. Do you see something that just can go away right now? Yeah, X over X, something over itself is 1. So those go away. You can ignore them. We're done with them. How do you factor the pink one?
You do a star method.
Star method. Okay, so if we do the star here, on top of our star, remember this is A is a 1, B is a negative 1, C is a 12, and your star is A times C, B A, and A. That means if I'm going to set up this one in a star, what goes on top of my star? A positive 12, right? It's 1 times 12, so 12. So that's going to go here. What goes on bottom of my star? Your B term, the -1. So you are saying, and then your A term is 1, so you can put 1s in there. Yes, ma'am.
I have a question. How did you get the x to the x to the second for the denominator?
I factored out an x from both of those. So I put that x out in front, which left me with an x squared and a minus 16 here. So I just,
If it's 3, we just take 1 away.
essentially you're taking 1 away. You're factoring one of them out.
The one is sorry. On the outside.
X to the first is on the outside. Yeah, so like if I thought of it in reverse, right? If I distributed this, that's x to the third minus 16x. That's what we started with, right? I just factored that x out of it. Eli?
Is it 4 and -3?
Yeah. Yep, so what can you multiply to get 12 that you can add to get a negative? Oh, I lied. -4, positive 3. Right, because you want a -1 when you add them together. So -4, positive 3. So you're going to write that as x minus 4 times x plus 3. How are we doing so far?
Great.
Is that making sense? Okay, can anyone tell me how this one factors?
You can square root 16.
Uh-huh.
And then it becomes x.
And the x squared. Yep. So this is a difference, right? Subtraction of two, what? Perfect squares. Okay, so difference of squares, remember that's the one that factors like this. It's going to be a plus and a minus, and then you're essentially square rooting the first and square rooting the last to get an x and a 4. So that's what's going to go here. X plus 4 times x minus 4. How we feel about that? Good? Okay. From there then, does it simplify at all?
You can get rid of the x minus 4.
You can get rid of-
X plus 3 over x plus 4.
Yes. So x minus 4 over itself is equal to what? 1. So that 1 will 1 out, right? We can just ignore it. It doesn't change anything anymore. So you get x plus 3 on top, x plus 4 on bottom, and that's as far as you can go. Please don't try to get rid of those x's. It's a binomial and a binomial. If the binomials are the same, you can get rid of the whole thing. But if it's just a part of it that's the same, you can't get rid of it. Okay? Okay. I want you to try this one now that we just did that last one because there's a lot of similarity. See if you can simplify that, and then we'll do it together in just a minute. How did you do? Tell me what you got. Oh, I don't have it worked out, so I don't even know what the final answer is. Tell me what you got for a final answer, and let's see if we got it right.
X minus 4 over x plus 4.
Anybody get that?
Yeah.
Anybody get something different? Okay, let's work it out. So star method for this top guy is what can you multiply to get 16 that you can add to get -8? What did you get there? Both of those have to be negative because if you're adding to get a negative but multiplying to get a positive, they both have to be negative, okay? So x minus 4 times x minus 4 on top. How does x squared minus 16 factor? X plus 4, x minus 4, right? That's a difference of squares. It's the exact same one we did over here, okay? So you square root them, and one's a plus and one's a minus. What simplifies from here? The x minus 4. So really you're left with x minus 4 over x plus 4. Hear me in that this does not equal -1. It's tempting for some to just reduce that, say our x's go away, and we get -4 over 4, which is -1. It is not, okay? When it's a binomial, you have to keep it binomial over binomial. If the whole thing can 1 out, then you can 1 it out. But if the whole thing does not equal 1, then you can't do it, okay? Good there? Okay, now we're multiplying. And there's two ways you can do this. And I think I said this on the quiz, or on the review video that I did. Or the lesson video that I did, but I don't know. If this is your setup, what's one of your options for how to solve this? Multiply straight across. So I could right now go 3 times 21 is 63. What's x times x? X squared. And then y cubed times y? Y to the fourth. Okay, put that over. What does this become? 42. X to what power? X to the second. Y to the sixth. Okay, so we're just adding our y exponents on that. So you can start the problem like this, and then what would you do from here? Divide both by 7. It's essentially what we did on that very first problem, right? Now this looks like our first problem all over again. So once you've multiplied across, you follow all the same rules you did before. Plug this into your calculator, hit 63 divided by 42. By the way, this is not 42 divided by 63. If you do that, you get the wrong fraction. You're gonna flip your fraction over, okay? 63 divided by 42, what does that reduce to? Second PRB, what'd you get?
It's like 1 and 1 half. So that's why you have
Did
to-
it turn it into a mixed number? So then you have to use the other fraction button. You've got multiple fraction buttons there you can do. So if that's throwing you off, you can always reduce your own way. 63 and 42 are both divisible by what? 7. So if I divide by 7 on top and bottom, 63 divided by 7 is 9, 42. Oh, there's a bigger one even, because that's 4 and 9 and 6. Yep. So if you divide that by 3, you get 3 and 2. So your most reduced fraction would be this. That means, oh, they're both divisible by 21. Yeah. But anyway, just keep reducing a fraction until you can't reduce it anymore, or use your calculator. If you're not sure how to not get the mixed number, I can show you that in a little bit. I gotta look at your buttons because they're different than mine. Okay, so you get a 3 over a 2 for this part of it. So we're done with the numbers. How about your x's? They go away. Yeah, they're the same. They 1 out. That's equal to 1. How about your y's?
Y to the second because
Where? On the bottom. If you subtract this, 4 minus 6 is a negative 2. To get rid of the negative, we move it down, or you just put it with the bigger number. So y squared, so this is your answer, 3 over 2y squared. Okay. Okay, now we get a little fancier again. So now you have binomial, binomial, trinomial, monomial. You have all these different sets of numbers. Anyone see one good place to start? What can you do to any of these?
2 y plus 2 divided by 2, and then becomes 2y plus 1, and then you could do star method on the bottom.
Okay, so if we factor out a 2, this numerator will be 2 parentheses y plus 1. Okay, so this becomes that. On the bottom, and here's where you have to be a little bit careful with your star method, we can do star method. Is there a GCF for this one? No GCF. Okay, so if there's no GCF, here's your A, here's your B, here's your C. When you set up your star, what's your top number? It's a negative 15. It's A times C. So a negative 15 up here. What's your bottom number? A negative 2. What's your A term? 3. I feel like that's where people usually forget to change the number. Is A right now is the 3. It's not a 1 anymore. We did a lot of 1s. This one's a 3. What can you multiply to get a negative 15 that you can add to get a negative 2? Negative 5, positive 3. So here's one binomial. That's going to be 3y minus 5. Okay. Your other binomial is what? What are those 3's gonna do for us?
They're gonna,
Make it 1 over 1, and that will be what?
1 for
Y plus 1, right? 1y plus 1. Did you process that? Is that working? We got it?
the girl who came to help us, like, mentioned things. She, like, flipped it.
Flipped it?
Yeah, she flipped, like.
Oh, was she doing division?
I don't remember, but she, like, flipped.
It was at the very end,
Yeah.
and she flipped the two fractions, 8 over 8 and 3.
Oh, she was treating it like division. Don't flip. No flipping. I'm not doing any division with you. Okay? Okay, so this right here is now this. Okay, we just have factored it. Okay, move on. Is there anything you can do to a 3y minus 5? Can you factor that? Is there a GCF? We're eventually going to cancel it out. For right now, we're just going to leave it be. 3y minus 5. Is there anything you can do to an 8 to simplify it? The answer is no. It's just an 8. Okay, so now you're here. This is your factored form. You have a 3y minus 5 on top, and you have a 3y minus 5 on bottom. So with multiplication, it's essentially making this one big bar, right? So that means this over this is 1. They go away. What else can you do on this one? Y plus 1 over y plus 1 is 1. What are we left with right now? 2 over 8. Is that our answer? Why not? Reduce that fraction. What's 2 over 8? 1 over 4. That's your answer. Isn't that lovely? You went with this to start and it became 1/4. It's beautiful. Love math. Love math. Okay, last one. And then I guess we've got some downtime. We'll play a game today. Since, unless you want to take your quiz.
No.
Okay. Tell me, actually, you try this one. You try it. Now that we've done the previous one, this one's got some similarities to a bunch of the things we've done. Try to work that out. I would love to know, because I got something real good going on. And then you can see how the crowd works. Up or down or left or right. Because remember, this tells you up or down or left or right. So plot those points. Your vertex is what you evaluate. So maybe call that your HSA. And then your graph. The graph. Yes. Can you wait till he gets back? Yes? It's a question.
No,
Yeah. Then it would just stay as x fused. Right? You factor out an x, you have x minus x. Right, so we just factor out an x. Okay. Are we close? Tell me what you did here. X squared minus 10x. What can you do to that? Caleb, you got some thoughts on it? What can you do to x squared minus 10x?
Don't you do the start thing on the bottom because there's 3 of them?
No, just this. What can you do with this?
you can divide by x, and then it becomes x in parentheses x minus 10.
You can factor out an x. You get x minus 10. Okay, how about this one, Caleb? What can you do with that one?
The star method.
The star method. Okay, so on the bottom, we're gonna do star. What'd you put on top of your star? Negative 70. What'd you put on bottom?
The
The negative 3. And what was your a term that goes here? That's a 1. Okay, so now ask yourself the question, what can I multiply to get a negative 70 that I can add to get a negative 3?
A positive 7 and a negative 10.
A negative 10, a positive 7. So here's your two binomials, okay? On bottom here, we have x minus 10, x plus 7, okay? Over here, we can't do anything to an x plus 7, so we just write an x plus 7. We can't do anything to an x cubed, so we just write an x cubed. Okay, now remember, when it's multiplication, you're essentially multiplying straight across. So I can just turn this into one big division bar. Everything on top is my numerator, everything on bottom is my denominator. What can I do to that? Jason, what would you do next?
You cross out the x minus 10.
Okay, x minus 10s go away. Logan, what would you do next? Is there anything else that goes away?
The x's.
Okay, what can we do with our x's? So you have an x on top, you have an x cubed on bottom. What is that gonna leave you with?
X over x squared.
Not, well,
It's one,
yes,
right?
but to simplify it, it's what?
Isn't it just 1 on the top?
Right now it's 1.
1 over x squared?
Yes. Oh, the number 1 you're saying on top, yes. So if you currently have an x over an x cubed, right? This is x to the first over x cubed. If we subtract those, there's an x squared on the bottom. Well, you can't just write something like that, because then there's nothing on top. So what is actually on top? A 1. Okay, so you simplified those to this. Is there anything else from this original setup we can simplify? The x plus 7s. X plus 7 over x plus 7 is 1. So all you're left with is what we simplified with our x's. So that's your answer. How'd you do? Got it? Okay. So does it say you have a review due on Tuesday now?
I already did it too.
Let's double check that so I don't make a mess of your schedule. When's May 9? Yeah, take a picture of it or a scan of it would be lovely and submit that to Candace. And then I have Nicole to compare it.
How much time do you have left in class?
12 minutes.
Yeah, I would.